Hi there, thank you for joining me in this video about tangent line problems. A standard problem in calculus is to find the equation of a line that is either tangent or normal to a curve at a given point. To find the equation of any line, we need to know a point that the line goes through. So let's call that line, or that point, x1, y1, and we also need to know the slope. So essentially we just need to know the point and the slope, a point and the slope. So in the case of the tangent line, the slope can be found by just using the derivative. To find the slope of a normal line, we need to know the word normal means the word perpendicular. And the perpendicular line is just the negative reciprocal of the original slope, okay? Or the slope of the tangent line. So let's go ahead and walk through a couple of basic examples. The first one says to find the equation of the line tangent to the graph at any point, at the given point x equals 2. Well, the first thing is that I don't know the point f of 2. So that's what I'm going to do. I'm first going to find the point, and then I'm going to find the slope. Okay? And the way I write my point is I write f of 2. So I need to say that f of 2 equals something. And the slope I'm going to write as f prime of 2. Okay? So let's go ahead and find that point. F of 2, let's see, f of 2 equals 8 minus 24 plus 14 plus 3. Now I did that kind of quickly, but 2 to the third is 8. X squared is 4. 4 times 7 is 28, not 24. And then 7 times 2 is 14. And then I have the 3. So we're good. So negative 20 plus 17, and I'm getting negative 3. So my point, f of 2 equals negative 3. The way you can say that is you could just say 2 comma negative 3. So that's your point. The next thing we'll do, and I'll do this in a different color, is I'll find f prime, but I can't find f prime of 2 right now, unless, if I need to show work, then I need to go ahead and find the derivative based on x instead of based on 2. So let's find based on x, it's 3x squared minus 14x plus 7. And that's the derivative. So after we do the derivative, we can find f prime at 2. 3 times 4 is 12. 14 times 2 is 28. And we have 7. I'm not that great at 12 minus 28, but I'm better at negative 28 plus 7. That's negative 21. So now I just do 12 minus 21. Let me see. I'll have a calculator. And that, of course, is negative 9. Okay, so what this is that our slope is negative 9. All right? So let's write the equation of the tangent line that goes through the point 2, negative 3, and has a slope negative 9. Well, before we go too far, we need to remember the point-slope formula, which has been taught in previous classes, and maybe even previous courses. So here's your point-slope formula. The way I like to use the point-slope formula is a little bit different than the standard form. Point-slope formula is typically something like y minus y1 equals m x minus x1. And instead of doing that, I like to go ahead and solve for y. So let's put it in this form as our final answer, okay? So if I have the point 2, negative 3, then that means that 2 and negative 3 will go there, and then my negative 9 will come out front. So y equals negative 9 x minus 2 minus 3. And this is my equation of the tangent line. Equation of tangent. All right, so that's the equation of the tangent line at the point 2, negative 3. What if you were asked to do the equation of the normal? I'll swap colors again. So equation of the normal is going to be y equals, well, I'm going to take -9, flip it, that's -1/9, and then I'm going to change the symbol. So +1/9, and the x minus 2 and the -3 stay the same because I'm going through the same exact point. Alright, and actually you don't have to simplify that anymore in a regular AP calculus class. Now, your teacher might ask you to do that, and in that case it will say write the equation in slope-intercept form, and all you'll need to do is distribute first and then add the like terms once you've distributed. But make sure you distribute first before you add the -2 and the -3 together there. Alright, so that's our first example. So let's take a look at an example that provides a bit more challenge. You'll see, though, that every tangent line problem I'll approach by first describing for the reader what is my point. Well, my point's going to be f of 2, but I haven't found it yet. And then I'm going to describe the slope. Well, that'd be f prime at 2. Okay? Okay, so let's go ahead and find the point. F of 2. F of 2 will be 3/4 minus 5 over. It looks like 3 times 8 on the bottom. That'll be 24. And using a calculator, you can get that 3/4 minus 5 over 24 is, drum roll, 13 over 24. Okay, so 13 over 24. So another way you could have written this point is 2 comma 13 over 24. Okay, so the next thing that we'll need to do is find f prime at 2. But instead of finding f prime at 2, we actually need to find f prime at x first because we don't have that display yet. Now, f prime of x is kind of difficult to find because our x's are in the denominator. So what I'll need to do is rewrite this with x's in the numerator so that I can effectively use the power rule. So when you move the denominator, the x's from the denominator to the numerator, that changes the symbol of the exponent. So now that it's written this way, I can better figure out that this derivative is -6 over x to the third minus, it'll be plus because I'm multiplying by -3. That'd be 15 over 3, won't it? 15 over 3 is just a regular old 3. -3 minus 1 will be -4, so x to the 4th. Now, it is optional to give these powers, to put these powers down in the denominator again. However, if you don't, then 2 is going to be a little bit more difficult to substitute in. Okay, so this is going to be -6 over 8 and 3 over 16. And we'll add those together by using a calculator again. So -6/8, -6/8, and then plus 3 over 16. Math, enter, right? Will give you -9 over 16. So now I have the slope, which is -9 over 16. Then we are going to write the equations. So the equation of the tangent line well, that's going to be y equals whatever the slope is. The slope's -9/16. X minus the x value of the point, so x minus 2, and then plus the y value of the point, so 13 over 24. All right, and then the equation of the normal I'm going to write that as y equals, now I need to flip this, so 16 over 9, and then I also need to change the symbol, so it's negative there, I need to change it to positive. So 16/9 x minus 2 plus 13 over 24. Now I have a great display on Desmos that I'll share with you in class if I see you. And if I don't see you, maybe I'll take the time and record a video of the Desmos display as well. So turning to the second page, it brings us to another type of tangent line problem. And it says that it involves finding the equation of a tangent line to the curve through a point that's not on the curve. And then thus we must find the point of tangency. The secret to this problem is calling the unknown point of tangency x comma f of x, and then we'll use slope and algebra and calculus. However, so let's just see what this problem entails for us. So what we'll do first is we know it's a tangent line problem, so we're going to write this point down, and thankfully we were already given the point 427. If you like function notation, you could have said that f of 4 equals 27 either way, but I think most students will get to this point and just enjoy writing the point more than function notation, but either way is accurate. Okay, all right, so the slope then, well, the slope would have to be f prime at 4, right? But we don't have f prime yet. So f prime of x is just going to be 2x plus 3, because I'm just using the power rule. And then f prime at 4 is just going to be 8 plus 3. And that's 11. So good. So we have the slope, the point, and the slope. And most students here would just say y equals, slope is 11, x minus 4 plus 27. All right, so let's take a look at that. So what I've done in the background is I went ahead and substituted in my equation to my function and the equation to my tangent line, and I pushed graph. And then I changed the window as well so that I could see y equals 30 in my window. So y max is 30 there. So then I push trace, and I trace over at 4, and it shows me 427. So the difference between this question and let's say another question that I was trying to write about up here in this paragraph is that this paragraph, the question in this paragraph might do something like this. It might give me the point 1, -6. 1, -6 is on the tangent line, and you would actually have to work backwards to try and find the solution there before writing the equation of the tangent line. So anyway, we're actually not going to walk through the type of question that is described in this paragraph because it doesn't show up often enough for us to spend the time on that. So what your sketch should look like on your paper is a lot of what you saw on the calculator display. It's a terrible looking quadratic actually. This quadratic should be like this, and maybe I'll put the point there, and I'll write the point 4, 27, and the red line is this equation, y equals 11, x minus 4 plus 27, and the black curve is just f of x. Okay, so maybe I'll just label this as f of x, and I'll label this line of the tangent y. Alright, so anyway, I hope that you guys enjoyed that video and gained some knowledge from that. Be sure to do some practice problems on tangent line problems. Okay? Alright, enjoy your day.